So now we'll define some notation about this area under a curve concept. In chapter 5.1 we defined the indefinite integral, integral of f of x dx, which was an antiderivative of little f. Here in chapter 5.2 we're defining something called the definite integral, and it's definite not because the other one is fuzzy or anything, but because it has a definite starting point and ending point that the other one didn't have. And we're calling that the area. In the new interpretation we have of area under the curve f of x down to the x-axis, starting at x equals a, going to x equals b, and any regions where f is negative count as negative area, like we just said in the last video. So let's go back to our driving time and speed problem. So assuming that the position at time 0 is 0, how can we write the position at time 4? We said that was the sum of those box areas. And now we're going to write that, since we have this new notation that says the integral from a to b of f of x is the area under the curve, which is the sum of those box areas. So we've got the integral from a to b of what? How do I write this sum of the area under that curve, or function? That curve is v of t, and then times dt, just like we had f of x dx. And what are a and b here? We can say that's the integral from time 0 to time 4, v of t dt. And let's check the units here. What makes sense? V of t is in what units? It was miles per hour. And dt is in what units? Well, if time is in hours, then any subtractions of time are also in hours. So that's hours. So altogether, we get units of miles, which is what we actually want for units of position. So earlier, when we were talking about the integral of f of x dx, we said, what is dx? And I said, it really is a multiplication. And that's showing up here, too. If that wasn't there, we wouldn't get the right units for total position. What can we do with this and the pumped hydro storage? What kind of integral can you write for that? Let's say I of t is the inflow rate at time t. And then what's the net inflow this week? Remember, net means total after accounting for stuff coming in and stuff going out. Like net profit is revenue minus cost. So what kind of integral can you write? It would be the integral starting at time 0, going up to time 168 hours per week, I of t dt. And what were the units on that? I was million gallons per hour, and dt was in hours. So altogether the units are million gallons, which is indeed an amount of water, right? So another way to say the distinction between chapter 5.1 and 5.2 is that 5.1 had indefinite integrals. So indefinite is kind of like, this is going to go on for an indefinite amount of time. That's a way of thinking about it without a known stopping point, or starting point in this case. So for an indefinite integral, the answer is a formula involving usually x or t. Of course, it could be any other variable you want, but usually we use x or t. For chapter 5.2, definite integrals, the answer is a number, usually not involving the variable that we were working with. In fact, it better not involve the variable we were working with. So next we'll put this to use on little subintervals of our driving time situation.